KM6ZTH here with the 2 Meter Crew Anti-Net. Welcome all. We want to invite anyone and everyone to get out here, get on the air, and join us on the 2 Meter Crew Anti-Net. We'd like to thank the
Anyone and
Whiskey
everyone to get out here,
for
get on the air.
hosting and allowing us to be on their repeater, as well as the Contra Costa Fusion Network and all other repeaters that are hosting this net. We will have a time for some check-ins in a bit, but first, we want to remind folks that should there be any priority traffic, we will absolutely stop. Simply let us know that there is to brake, and we will make room for that emergency traffic. Is there any emergency traffic at this time? Hearing none, we're going to go right ahead and kick off the 2 Meter Crew Anti-Net. And before we get into our main topic tonight, let's make a quick call out to any new hams. This is like your first time on the air, you've been listening, but you can now legally transmit. If you're on any of our digital modes, if you're on analog, come one, come all, if you're a brand new ham. All right, hearing none, we're going to go ahead and kick this back off, and we're going to get started tonight with a fun topic. And we got a special person here. There's always lots of questions around this, and so we thought we'd bring in somebody who might know a little bit of something about this. So the real question is, are you grounded? And should you be? So, Kellen, KN6ETV, why don't you give us a little tour of what we should be thinking about when grounding our stations? There's lots to think about, I believe. KM6ZTH.
All right. Well, being grounded is a good essential to have in your shack. It should probably be your number one consideration for your safety, your families, and anyone around you. Nobody wants to get shocked. That's a reason why we all call electricians to work on our houses. So we're pretty much just going to go through a couple of hot points on what to maybe avoid, what kind of components to look for. Ground rod placement, that's a big thing. There's a couple of things with the NEC that actually says ground rods should be placed at least 6 feet apart. But there's actually a phasing that goes around a ground rod, so it actually should be placed a little bit wider. And I'll kind of give you a little diagram to kind of show you how far apart a ground rod should be from another ground rod. So you want to make sure that you actually have everything appropriately sized and appropriately spaced away. And I'm kind of going to go around just on the outside by your antenna first, and not really get into the shack too much. As long as your components on the outside will be your first priority to make sure nothing is coming into your shack. That's mainly what we want to protect. So I'll go ahead and break for that. Is that enough? All right, let's do it. All right, so I got a little PowerPoint that I've had to relearn how to use again. So I will go ahead and try that again. Let's see, screen share. Bam, bam. Give this a whirl. All right. Start. Okay, so y'all see that? Can't tell. There we go. Is it good? Okay, so same thing, just a little bit of grounding and some wiring methods. These are what ground rods look like. They are a zinc coated, actually has a certain amount of zinc. They have a copper cladding that goes over a steel core. So you can actually hammer it in and not worry about the ground rod actually bending, mushrooming. Sometimes they will bend if you give them too much side loading, but generally they do go, directly where you want to, without, no crazy rocks or anything that's in the way. There's something I did not give you a picture of, which is a galvanized ground rod. Some places will ask that you put a galvanized ground rod in, just because of they think the copper is going to erode or other things. But technically, this copper ground rod actually has the same amount of zinc that a galvanized rod has. So there's not really any kind of gains, if you will, from a traditional ground rod. So we'll go ahead and move along. So this is a acorn grounding. This is what you're going to find at your local box stores. The left picture is the actual what it looks like. Some of them come with a stainless steel bolt, so it doesn't bond to the copper, doesn't corrode, oxidize, or anything like that. The stainless steel is a dissimilar metal, so there's less issues with any kind of corrosion or something going to it. The middle picture shows the ground wire actually connected on the bolt side, which is a incorrect install. You don't want to do that. What happens is the wire doesn't get full connection to the ground rod or the bolt because a couple of those strands can actually fray out and you're only touching a couple of points. So on the right side, you actually see another acorn with the wire on the back side of the ground rod. So that's what happening is the bolt's actually pushing on the ground rod, which is then putting pressure against the actual clamp. So that'll get you full adhesion. And then there's massive amounts of people that say to don't even use an acorn because technically you can get a lot more surface of the wire that can actually have corrosion involved. Granted, all of these are direct burial methods. So technically you will be correct per the NAC if you put this in. Granted, I'm still kind of new to the RF game, so I'm still learning what doesn't act as a counterpoise and antenna and things like that. So this is just my recommendations per NEC wiring method. These other two clamps, one is a 3-piece. The screw on, or the item on the left is actually a 2 bonding screws that actually clamp down to give you a nice even force around the ground rod itself. The center screw will give you a size up to a number 2 solid wire. This is the most common issue or most common item you'll actually see. It can actually cost like $2 more than the acorn style. I would tell you if you have an option between acorn and that one, I would tell you to pick this one just so you get full adhesion between the ground wire and the actual clamp as opposed to just going directly to a rod. So the rod bonds to the clamp and then the clamp goes to the wire. So you get a little bit of a differential and each one's tensioned on its own. The third one is on the right-hand side. This is a U-bolt style. This is the style I prefer. You actually get a larger surface space going to the ground rod. It's a full brass or a copper plate that actually touches the whole radius of the ground rod up to, I believe it's, let's see, an inch of depth. I've actually got an extra one in front of me. With this particular style, you can do 2 different styles of wires going vertically through the actual 2 clamps. The wire goes through the 2 pieces, and then it also can go horizontally across the clamp. You'll see in some other pictures I took of my own install, it actually runs horizontally across the ground rod. But that is also another thing where it actually separates the wire from the ground rod. So there's no potential for oxidation between the wire and the ground rod. There's always a clamping surface between the objects. This is actually from my own tower install. I have 3 separate ground rods. Each one you can see I kind of use the same clamp. It's just a loop is what I did. It's just a big halo. So it goes into the one on the top left, goes through that clamp, comes down into the pipe, into the middle, does a nice little loop, and then actually out to the right-hand side. You'll notice I didn't actually strip the whole copper wire. This is a means so that the copper wire actually lasts a little bit longer, so that there's no oxidation on the wire, because what will happen is you put a pipe in the ground, it's going to fill up with water. Over time, that wire, that copper wire is going to turn into a nice Statue of Liberty. It turns to a nice green color. So it's going to have a lot of oxidation on that. Another method of connecting a ground rod to a wire is CAD welding, exothermic welding. So there's a picture on the left-hand side. There's an older style of way to do it. You actually take a mold, you clamp it around a ground rod and a ground wire, and you can actually fill it full of thermite, and you actually ignite it with a little bit of striker after you make sure that the mold is nice and firm and tight. If it's not, it actually blows apart and makes a big mess and you burn yourself. It's not fun. But that is the preferred method. It's actually most industrial sites will actually do an exothermic because you get the least amount of resistance on all your ground rods. The picture on the top in the middle is actually the newer style. You actually drop in a little K-pod, like a little coffee pot deal. You drop that inside of the thermites. That actually holds the thermite. You drop that inside the mold, and then you'll stick a 9-volt battery essentially to it, and it actually ignites a igniter inside of that. So the upper right-hand corner, you see a picture. It's actually of the interior of the mold. It's a ground rod comes in the base and a wire comes across. You can actually see kind of how the thermite would come across. And then on the bottom picture just shows you a couple different methods to bond additional wires, because you don't always want just one wire connected. You want to try and interconnect all of your grounding methods into one continuous mesh, if you will. So this is where we get into rod spacing. Because of the certain, whenever you send an AC signal down a ground rod to actually measure it, you're also measuring the amount of resistance you're getting out of the rod. The effectiveness range depends on soil conditions. If you have a really rocky soil, you might have to add additional ground rods to make sure that you're getting a low enough resistance on the actual ground rod. If you put them too close, what'll happen is you can see in the picture that they actually overlap. So whenever you have a ground fault or a lightning rod or something like that, lightning strikes, it's actually going to overlap, and it's not an effective grounding path. It actually hurts you when you think you're having optimum amount of grounding. So in the NEC for your home, they'll actually say that you need to have a ground rod spacing of at least not less than 6 feet. I kind of have an issue with this rule because most ground rods are 8 feet long. So you actually need to space your ground rods accordingly, so that however long the rod is that you're using, you need to space that the same amount of space away from the next ground rod. So if you're using an 8-foot rod, you need to go at least 8 feet or more from that other ground rod to give you enough bubble space around your ground rods. I would encourage you to never use a 4-foot ground rod. You actually cannot get the resistance you need out of them. You actually need to add several of them to try and get the low enough amount of ohms out of them. Should I drop? I don't know how much I'm talking. I'm just kind of going. Okay. Oh, that's really good notice. KN6 ETB here for grounding. So like we're saying, use additional spacing when in doubt. Stretch it out. Go a little bit further. Don't be afraid to spend the extra $10 to make sure that you get effective grounding and run your wire just a little bit further away. It's not going to do anything worse for you. It's actually going to help you if you space it a little bit further away. If there's ever a time where you say that you're like in the Sierras here, like in California, we've got a lot of Rocky Mountains. If you're at a point where you can't sink a ground rod all the way down full depth, but you know that you can do at least 4 feet, you can actually dig down a nice trench that's the full length of the rod, drop that rod down at least 2 feet in the ground. And I say at least because the deeper you go, the better. And that'll actually give you a horizontal plane of that same radiation pattern. But you also need to account for the same length distance that you just put that on the ground. You need to account for that and put that as an additional 8 feet, 10 feet, or the occasional 20 feet. Those aren't fun. And actually space them accordingly to make sure that you're no longer within that effective radiating pattern. So this is the actual ground rod measuring tool. You can actually put this clamp around your ground rod, and it'll actually measure the amount of resistance that you have in your system. These clamps, not a lot of people own them because they're upwards of over $1,000. Sometimes you can get some of the newer stuff that actually plugs into your computer. So most electrical companies typically don't even own these things. They just go with whatever the NEC minimum is, to be honest with you. So you want to be under 25 ohms for each ground rod. Ideally, you want to have at least 3 ohms in your system or within that rod. The further you get away from your ground rod, the more resistance you're going to get because of the added resistance of the wire, and whatever size of wire you ran is going to add a multiplier of such resistance. So make sure that you get the appropriate size ground rod, appropriate size wire. The bigger the wire you can run, the better, because it's going to be the least amount of resistance to help you out in your grounding. If you are in an area where you have a lot of frost, that frost line is going to create a little bit of moisture is going to freeze, and eventually it's going to break your grounding. So you need to make sure that you're at least 12 inches below that frost line. So you just take that thing, hammer it down on the ground, wherever your frost line is, hammer it on the ground, connect it, and then you can actually backfill it and just make sure all your components are completely direct variable. Typically, I like to use all copper components. I don't use much aluminum because aluminum will actually corrode faster than the aluminum. All right, so now we'll get into my own personal install. I'll take a little step back here and let the reset. KN6 ETB with the tower project. So you can see this is kind of like the side of my house. I have a little tower, some concrete, and the picture on the left, you'll actually see a gutter on the wall. It's where I have all my coaxes coming in. I have a little bus bar that's inside of there. I have three 5/8 by 10-foot ground rods. I have those ran in a full loop. They're all 12 feet apart to make sure that I'm over the 10-foot restriction. I also made sure that I'm 7 feet from each tower leg. Depending on the tower you use, they're going to recommend that you install your ground rods so far away from the towers. This was a second-hand tower to me. I actually have a Roan 55G tower section in the middle of that concrete for any kind of future if I decide I don't want to use this telescopic older tower anymore. And then Roan only specifies just one 5/8 by 10 ground rod with a number 4 wire. I actually ran a number 2 that interconnects all the ground rods together into one big halo. So if there's any effective lightning strike, it actually goes into all 3 ground rods and not just kind of in series consecutively down the line. It actually will kind of spread out in a circle. And that's commercially, that's what the result halo all of the grounding together to make sure that you have one uniform ground. Excuse me. The actual commercial antenna installs, you'll actually have one ground wire per tower leg. But my tower is so small, and it being secondhand, I kind of went with my own gut on this one and ran only one ground wire. The way it was actually ran, there's a bus bar inside of that gutter. It's actually almost the full size of that gutter. So what it does is I have one ground wire. It's kind of making a loop, hits the tower leg first, goes to each ground rod, and I actually have it going back into that same bus bar. So it's actually all interconnecting, and there's no additional grounding beyond this to not cause any other secondary grounding outside of this, if that makes sense. So here's a kind of a tower leg connection. It's just a U-bolt with a brass that's making a full connection. I'm getting full pressure, full grounding on the tower leg itself, and then the ground wire. It has another set of 2 brass that actually touches the wire itself. These clamps, that particular clamp, you will only find at like a Home Depot or something like that. You'll have to order those through like an electrical supply house. The same thing goes for the picture on the right, the U-bolt style. You'll have to find those at an electrical supply house. All right, so this is the actual interior picture of my gutter. I have LMR 600 running down my tower to try and alleviate some of the losses that I have in there. The copper plate is actually a 20-inch by 4-inch, quarter-inch thick ground bar. It's actually used for a lot of data and telecommunication server racks. This is actually what bonds all of their server racks together, and including some ladder racking that they would actually put over them to run all their coax or their Cat5 zone. I'll take a break. All right, KN6 ETB. Also in there, you can see there's a little block in between the 2 coaxes. Those are called polyphasers. Those actually are filled with a inert gas, and it also has a little capacitor inside. So what happens is the lightning strikes, the DC does not pass through the capacitor, and the gas doesn't allow it to pass any kind of charge through. That is your primary defense against any kind of lightning strikes or voltage trying to come into your shack and harm your equipment. Now, your first response should be, well, you should disconnect your radios. Well, just in case I went camping and I'm not home, at least I have something as a first response that could help me assist in doing less damage, because inevitably it probably will do some damage. So hopefully I just burn up a little diode and not burn up my whole radio. Second thing is whenever possible, you want to crimp your wires instead of clamping. You'll notice all my ground rods are actually clamped and not crimped. Those are takes a specialty crimping tool to actually go ahead and clamp those down. Crimp those as a circumferential crimp. Any kind of bonding and grounding you want to do a non-irreversible method. And that's just because you don't want someone to accidentally come back behind you, disconnect it, or have a loose connection over time. So anytime you can crimp a connection, it's always going to be 100 times better than if you were to actually crimp it. And then the other thing is at the stores, you'll find a threaded lug. And it's actually, I didn't bring one with me, but essentially you can put a bolt to hold it to a clamping surface. And then it could have a set screw. And then you'd put that wire into that set screw and you tighten that set screw down. I would suggest that you don't use that, because over time you get something called thermal expansion. That copper wire or whatever that item you're using is actually gonna swell, expand and contract on the threads, just based on your climate. You don't know how things are going to react, and over time that aluminum or set screw or whatever it is, they're going to expand and contract 2 different rates. Eventually you end up losing a little bit of tension on that wire. So if you can do a actual crimped wire, it'll last you far longer than any other method you can do. So this is the same thing I just kind of went over as a polyphaser. This is actually the model that I run. It's a 2 kilowatt rated 1.5 meg to 50 megahertz. I just wanted to make sure that I can do full legal limit, because this is the one thing that you kind of want to do once. You don't want to keep buying products over time. Just, bite the bullet. I'm doing it 1 in 10 at a time. So I got a Yagi on the top of the tower. So I went ahead and I bought one of these first. And then I knew that antenna would be protected for however much of a strike I can handle, but I still got to disconnect my coaxes at my actual radio. So these things are, I think, $75 on DX Engineering. They're not cheap. I just now bought a third one because I have a third antenna that I'm gonna end up putting up. But I was, it doesn't have to be this exact model. They make smaller, cheaper ones. I think like Amazon sells them like $30, where it's a little ground wire. It's not perfect. It's not ideal. But those are helping, needless to say. I'll take a break. I think that's it. Yeah. So this is just pretty much, like I said, it's your first step in trying to be safe, to make sure that you block any kind of RF, or not RF, but at least any kind of potential currents or surges from coming into your shack should be your first priority. So you as an operator don't accidentally get hit by a shock. You don't get hit by a ground fault on accident. As far as, what is a counterpoise and what kind of RF leakage might occur coming back at you, I'm still learning that for myself. I've only been a ham for October of 19. So it's still new to me on that side of things, but I can only relate to what is on my NEC side. So that's kind of the start of my project. I did ground out my radios and my Amplin, my, what is this thing called? My antenna tuner. Those are actually all grounded out. But I still have some additional grounding to do. I got to put a ground rod in, and there's a whole nother aspect that goes into making sure that you don't create parallel grounding paths. Those are dangerous and can hurt you dangerously. So I encourage you to do some reading, and definitely dive in. Article 250 is probably one of the largest sections in the NEC. So if you think you have grounding down, I assure you do not. So anyhow, questions away. Well, there's a certain point of when you can't get a solid wire. I think solid wire kind of stops at, I think, number 2. At that point, you're really not bending anything. You're just bending solid copper that's not going to bend. So anything over that, you're going to get stranded. I would stay anything that's over a number 4 conductor, you're going to do stranded. You're not going to do anything less. But if your one system is, say, like a number 10 wire, I probably wouldn't do anything less than a number 10 myself. That gives you at least a 60 amps of potential current to run through that number 10 wire. I have stranded THHN on all my radios to my grounding surface. If it's exterior, I would do solid. Solid's going to take longer to break down and deteriorate over time, just because there's sheer less surface area as opposed to a stranded wire.
I can't do both of you on this.
Hope that answers.
So, Kellen, there was another question. You kind of covered it there, but what is the ideal for most people? What gauge wire should they be using for ground on their antenna?
That's gonna get kind of determined on the antenna. If you have a tower, go with your manufacturer specs. I mean, you can overdo grounding as far as grounding wire. In my opinion, bigger is always better in this scenario. The least amount of resistance is your friend. Any kind of lightning strikes that happened, or a power line that falls on your tower, is something, you know, ominous as that. Any kind of additional grounding you can do is going to be so much better for you. As far as minimal grounding, that if you know like what kind of potential currents your item runs, like my TS 2000, that's got a 25 amp, or it needs at least a 20 amp supply. So I know just by currents, if that thing were to do a dead short completely, I would need let's see, a number 12 is only rated for 20 amps, and then a number 10 is rated for 60. So I would just bump that up to a number 10 because I know my radio can handle, you know, up to 25 amp fuse. So I would want to make sure my grounding is a size appropriately to handle that. That's why I say just pretty much just go ahead and stick with a number 10 across the whole thing, the whole board, and you shouldn't have an issue. Even if you did a amplifier, like I have an old Dentron Clipperton, at 220, it still only pulls, I think, like 12 amps. If I did 120 volt, it's still 22 amps. And so I know I can put a ground to my bond, and it's still covered within a 10 gauge wire. But if I ran a 12 gauge, then I would have an issue of that wire potentially melting.
Right on. KM6ZTH here with KN6ETB and the rest of the 2 Meter Crew Anti-Net. We want to welcome some questions out there. If anybody's got questions on grounding, and if you didn't or you aren't able to watch on YouTube right now, I highly suggest you go back and watch this. That was a fantastic presentation, Kellen, on like some of the visual things for us to understand why or how you might choose something. That was really, really well done. So let's see if there's any other questions out there. Let's start with analog RF. So you may not realize that you're coming in on a digital mode, but if you're using analog RF and you've got a question for Kellen about grounding, come on back.
A lot of questions.
All right, Michael from Carmichael, KN6BXX, come on back. Go ahead, Michael from Carmichael, KN6BXX. Floor is yours. After that, there, Kellen.
I didn't catch all of that.
Okay,
I
well,
heard something about a foot underground.
so the basic gist here was he's hoping to understand if he has a copper water line that is buried underground,
Mhm.
could that suffice as a ground if you didn't want to drive a rod? Sounds like he's got a horizontal rod. I didn't quite catch the length either, but it sounded like it's buried a foot underground. So this is back to your horizontal that you were talking about. Would that suffice? What kind of grounding potential would that give? Or where should he be looking to get those answers?
Well, your water pipe should be bonded in your home. Given your home's age, your water main should actually be bonded to your electrical system, which should go to another ground rod. Additionally, your UFER in your home. Um, Given the components in your home, you could also be getting a little bit of RF feedback on that same mechanical ground, because that's not a true, well, that'd be an equipment ground. Um, that's kind of a dirty ground in a sense. It's not ideal. If it's what you can do for the time being, great. But I would encourage you to actually put a full 8-foot stick rod in the ground straight up. That's going to give you the best radiation pattern. And only being a foot in the ground, it's it is helping. How much I can't say without actually putting an actual clamp meter on it to say what it is. Um, that's a vast range just based on the soil content. Like if you have a lot of clay and a lot of water, it could be less resistive because it's gonna be really conductive. But if you're in a really rocky terrain, that rod could be doing next to nothing for you. Hopefully that answers.
Right on. Well, we've got Kellen here, who is you're an electrician by trade, right, Kellen?
Yep, I've been an electrician for 15 years.
There we go. So we have somebody who actually, lives this, breathes this out here, telling us what we're doing wrong or what we're doing right. And as he even acknowledged, right, like there's a difference here between we've got kind of a lightning ground we're talking about. Then there's
Yep.
our electrical ground for our radios and the potential that's there, kind of tied more to the house electric. And then there's RF ground that might be a totally different subject.
Oh yeah.
So are there any other questions out there in Radio Land, though? We want to see if we can answer anything for anybody out there. So whether you have a solution, whether you don't ground, and why you don't ground, let's go to the digital modes now and see if we get anybody out there with any questions on grounding.
Sure. I think part of that would lead into an RF portion of the grounding, as far as what's coming back on the shielding that's not coming back to your radio. It might dead end first. That part I can't really speak to too much of. That I would, all I can say is just on the safety aspect, I would tell you if you have a dipole strung up in the ground outside, wherever that coax maybe enters your shack, I would put some sort of a grounding protection method there. So that way, whatever happens on the outside, at least it's protected to a measurable point before it actually gets into your shack. I did want to add one thing is one thing that's like kind of interesting about ground rod testing is we're all talking about RF and AC signals kind of traveling through air and whatnot. Well, the actual way that that ground rod tester works is it actually induces through that clamp, it actually induces an AC signal into the ground rod, and it actually measures the AC signal that's being bounced back upon that meter. So one part of that clamp is actually an AC signal driver or transmitter, and the other half of that is actually a receiver. So that's actually what's measuring the actual resistance and effectiveness of that ground rod. So it's a little interesting, kind of overlays, if you will, the RF side of things, just as far as AC signal, and it's not just reading just a actual resistance value.
Well, I'm going to throw in a question, KM6ZTH, and that's where we start talking about the difference between, let's call it lightning ground for the most part, kind of what we're covering here. But also, do I need to bond that to my electrical ground, or do I have potential now because I've got these two different ground systems going?
So there's a little bit of here and there. It's the same thing as creating a ground loop. There's NEC kind of says one thing, tower manufacturers may agree to another one, saying local jurisdiction kind of has power to say what is what. The way I personally see it is if there's a lightning strike, I want it to go straight to ground. I don't want to blow up my light bulbs. Myself, even though it is connected to my house, I didn't tie my effective tower grounding directly to my home's grounding. It's not that far. I mean, really, I could run a 10-foot wire and actually connect to my home's grounding. But I don't know if that's also going to induce any, because my home is now having a dirty ground because I have the loads in the home going down the ground rods, because your neutral in your home is actually created through your ground rods. And so all that load from your house is actually traveling through those ground rods. So if you connect that to your tower and you actually get a lightning bolt, effectively you can, if you're not dissipating enough voltage, you can actually run that backwards into your home system. So there is some say, according to some folks, that you do not want to connect your lightning system to your home's grounding system.
Well,
but you have to
like
do some more reading on that
some,
one.
It sounds like it also might be a little bit of a noise enabler too, right? If you're tied to your electrical system, right, your RFI could easily be tied.
Oh, you're definitely going to get something. I'm sure it's measurable on some scale, but depending on who your neighbors are, I mean, those could be emitting more RFI than actually what you're emitting into your own grounding system.
Hey, I got a question here. I see Shane on the YouTube is asking what depth for ground wires between rods. Is there like a recommendation for that sort of stuff that you can help us out with here, Cal?
The actual wiring itself doesn't have any kind of ruling to say that wire needs to at about a certain deal. I actually, if I go back to some of those pictures, you'll see that I actually ran a 1-inch conduit between the two ground rods. So if any point in time, if I find that my grounding is failing and I need to replace a section of wire, I can actually remove that wire and pull in a new wire, put it back to the ground rods, and it's no issues again. I think Roan actually tells you to run the ground wire directly in the ground at a certain trench depth. But again, that's per the manufacturer and whatever wiring that they recommend. Like I just found out the other day from another ham radio operator on Discord that he actually uses the same guy wire as what is recommended from the manufacturer to actually run his grounding to the tower, which I didn't think you could actually run a steel cable and use that as your ground wire. News to me. So yeah, there's no code saying that it's got to touch earth at all. It's just got to go to a certain ground rod and be measurable to a certain point. To answer your question, Justin, about potential between your home's electrical grounding and your tower grounding, if you were to actually disconnect those, you can actually measure a potential between the two grounding systems. One based on the amount of grounding field is in one area and what's being returned path and the loads like we were discussing. And then also the soils could be vastly different within 10 feet. So, I mean, if one's not dissipating as much as you would hoped, or it's, you didn't measure it, but it's, only dissipating half of what it should be, and the other one's working really well, you're actually going to see the differential between the two with a voltage meter.
That makes a lot of sense. Well, we want to keep the anti-net going, but we think it would be fun to get you all a little bit more involved. So we're going to go ahead and drop everybody into Zoom here. I think we could have a lot of fun here. So we're going to wrap up repeater land a little bit earlier than usual tonight. So if there's anybody who wants to jump in real quick with a last minute check-in, we're going to take a few of those. I might stick around on the repeater to grab those and help deflect you all over into Discord. But please come join us, have a chat with Kellen, get your questions answered about grounds, and tell us about what you do over in our Zoom. So the Zoom link is now dropped, and we'll be moving over there shortly. Any last minute check-ins? Uh, didn't catch the call, but Richmond, Virginia, go ahead. Area. So, yeah, you should come join us over here in Zoom. We can talk a little further. There was a couple different ideas going around with that, and we'd love your input. So, check out the YouTube and come join us. All right, we're going to wrap things up here in Repeater Land. I will stick around on the repeater to take the last few check-ins, but the folks over in YouTube Land are going to move on over to Zoom only. So feel free to join us. Wrapping up the Anti-Net, KM6ZTH would like to, and the 2 meter crew, we'd like to thank all the owners of the repeaters we're on, from the Freestar Connections, and specifically the Coco Fusion folks and the W6BVR Club for the use of the repeaters. The repeaters will be returned to their normal use. KM6ZTH clear.
In a condo, yeah. I'm like upstairs in a house. Upstairs. Nothing. Nothing. Zero. Yeah, I had inside or invisible outside. Yeah, yeah. Well, I've made contacts abroad. I have made contacts abroad, but it's a bit more of a challenge. Mag loops and end feds, 49-1, 9-1s. That's right. Yeah, yeah. I have had some. I have had some super contacts just using something like the ASU 857 and a telescopic aerial in the back of it, just sitting on a table. Straight into Russia. I've done that before with no counterpoise or anything. Reasonable SWR, but just good conditions.
There's a way you can still ground that is if you you have a 3-wire system still, right? Because I'm guessing where are you located exactly?
In the UK, Kimmel,
Okay,
Callum.
so you guys still run on a 220 volt system with a 3-wire with a ground. So you can actually just go to like your local box store, buy a 3-wire plug connection, and then just run a ground wire directly to the grounding pin, and then put that to a little ground strip, if you will. It's got a couple of terminations, and then you can run your actual radio off of those. So it gives you a little bit of. I see Justin trying to jump in. Oh, maybe not.
Yeah, I'll look into that. Yes, thank you.
But yeah, you can get at least get something that'll help you with something.
Yeah, right, I'll look into that. Thank you. Yeah. Back
Lively
over to
bunch.
Nick.
Can you hear me now? I had the microphone plugged in. Anyway, yeah, how are you doing there, Nick? How's it going? Are you guys bone chilling up there? Yeah, I think we in California got spoiled. We didn't get quite the bone chill the rest of the country. It's like unbelievable. Like, wow. Oh, really? Wow. I was gonna say that my wife's friend, Linda's friend Patty, her husband live up in Poulsbo. They live, a few miles away from the sub base, and they had not snow, and their huskies loved it. So yeah, but yeah, great presentation, Kel. It's good to talk this morning and see your presentation on grounding, and your electrician experience has been a real asset to tonight's topic too.
Thank you.
And there's Bobby Lee. How you doing there, Bobby?
Oh, I missed every freaking thing.
Well,
Tried so hard to get over here. Oh,
Okay.
it's 6:30. I got this. It's 6:45. I got this. And half of HRO showed up at my house. And I'm doing a custom install for Tim next weekend.
Well, remember you're saying, Bobby, make the most of it, enjoy the rest of it.
Just make the best of it, enjoy the rest of it.
That's it, man.
But you know what the new one is? Stay positive, test negative.
There you go, Bobby. All right, man.
Yeah, for sure.
Comment. Only comment.
Yeah, but I had Tim over here, and I was consulting with him doing an install. He's got 4 radios he wants me to put in his car.
Oh, wow.
I'm all, this is gonna be so easy. I'm all, dude, just put this here, and there. And then I got into his little Kia Rio, and I'm like, oh crap, that can't go there. That can't go there. This needs to go here. And then next thing you know, it's 7:45. Sorry. I tried, Nick. I tried. Yeah, they
What's-
call it amateur operator for a reason.
You're kind of
What's OBS? As far as I know, it's a diesel.
Yeah, it is.
Open broadcasting software, man.
Oh yeah,
Good stuff.
you tech-friendly kids, you.
I thought it meant it's bullshit.
What's that too?
Hey, I do have Sandy's bug out box here if you want to take a peek at it. I don't know how good I can do, because I'm a shitty videographer, but if you guys want to check it out, I'll put it up here on the bench and see if it
You don't have to give it to Sandy. We could just give it to one of us.
right? But actually, like, see if I can get this
Wow.
to the camera. You can see here's the antenna. Now this antenna port is just a PL259, so you can put any. Obviously, when it's sitting there, you can put any antenna on it. Right now, it's got an MFJ 1717 PL. That will sit when the box is actually sitting like this. The antenna, will be raised up, something like that. If you're just doing bench, picnic bench portable or whatever you want, you've got AC in. Now this is pretty bitch, and I love this. This is so she didn't have to run a cord through it while it's charging, but there's your AC in port. Okay, here's your cigarette lighter. All right, and on the front, you can see there's the power button. There's your voltmeter. You can see it's up and running right now. On this side here is your dual USB ports. You can see that it's all fired up. In the back here, take this back here. There's dual Anderson power port back here with solar power input. I hooked a 260 watt solar panel to this with a PowerWorks solar controller that has, what do they call them? MC4, I think, or
It's an MC4.
MC4 to Anderson. So the Anderson plugs into here. The MC4s plug into the solar panel. It's pretty bitchin'.
So is that
So
a power
of course
in and a
of course
power
I
out?
did some custom stuff for her. You got ham radio. That's where she bought a lot of her stuff, and there's her purple KN6 GST.
Oh, that is cool.
So I'll open this thing up here, and I'll bring the camera down to it. But right here, if I can get this here, you'll see I put a. Maybe I can get a little bit better lighting here for you guys. Hopefully the thing doesn't fall off the bench. I'll back up a little bit. So there's a lid organizer in here that's going to host her cables. Right there, you can see kind of in that pocket there, one of her jet packs that will run this for her Pi Stars. I did something kind of cool. There's a mirror up there that goes all the way across. Let's see if I can do this. The mirror is designed for her to be on a picnic bench or whatever doing her operation, and Slim Shady comes up to do an arse grab. She'll see him. You can see the Bobby Bug Out Box emblem right there at the top, designed by Aaron. And right below it is a magnetic mic holder. You can see her call sign. So I'll back up, and you can see that this is on everything is weird and backwards. So I'm doing my best. Bear with me here. Well, do I go left? Do I go right? But you've got a full working surface here. Okay. Let's see if I can do this now. I can't put that in my mouth and talk at the same time. But let's see here.
Bobby,
Sure.
how many lids can you organize? You got a lid
Right.
organizer.
Right, check this out. So if I can get this here up in here. Now inside hosts her iPad. We're just gonna leave that in there for now. Right on this side, there's the FTM 300 control head. Okay, now I'm just gonna take this out. And if you just bear with me for a second, I'll set it up. It'll take me 2 seconds. I put the control head here. She's got 2 metal plates in here that the control head, I customized the magnet underneath the mount Okay, I'll go ahead and pull the iPad out and I'll just set this up real quick. And just so you get kind of a basic idea, because her laptop is designed to sit up here as well. So now you see the FTM 400. I'm sorry, I said 400. I meant 300. I'll just see if I can turn this on without knocking it off of the shelf. Okay. So this way. Okay, you can see the control head mounted up there, up, where the lid organizer is. Okay, when you come back, you can see her iPad sitting there. And if you look up here, there's her microphone. This is just sitting up there with a this cool mic mag mount. And so now she has a complete work area. Her laptop is usually, everything's backwards, sorry. Her laptop can sit here, and it also hosts the iPad. So laptop could run, let's just say QRZ if she's doing, if she wants to do some logging. The the iPad is there to host maybe her Raspberry Pi dashboard. Okay, and then if we were to take everything off here, I'll try to get this light. I'm going to put it right on my chest here and see if it'll get up in there. So now when we look in here, this is a shelf here. Let's see. Oh, where is it? Over here. This is where the iPad resides. Right on the back of it, if you were to go right over here, the cord, the AC cord will stash right by the Bioenno battery. There's the 20 amp hour Bioenno. Here's all the good stuff. Now underneath those wires is an Epic Power Gate that is going to be your power management system. So you have AC in, DC in, and solar in, and charge out to the battery. So when this thing is not plugged into the wall, it's running off of that Bioenno. Let's see, I wish I could get some more light. I'm trying to not be too wiggly.
I got a couple questions.
Yeah, go for it.
Your Anderson ports on the backside, are they bi-directional, so you can use solar and so you can put power in and out at the same time, or is it just one or the other?
They are that absolutely. They are bi-directional, as you said. So you have whatever the hell you called it. Yeah, they're just like a bisexual. They go both ways. So you have
bi-directional. So it's a power in and a power out.
Something by something.
Bi-directional, yeah.
So you have solar input and you have power output if you want an additional power source with Anderson PowerPort for whatever. On the side of it, you got dual USBs, you got a cigarette lighter plug. It will literally run the iPad, it'll charge your cell phone. It's running your Pi-Star, all of those things, so it's quite diverse. It's got an MFJ power supply in it. I just leave it on, so when you pull the power plug out of the socket, it shuts off and it automatically runs off the battery. Now I'm probably going to say this wrong. Is it, because I know we got an electrician here, is it a parasitic drain where it's similar to an off-key drain? So if you have things hooked up to it that can drain the battery when nothing's running.
It's like an LED light that just continually runs.
Right. So I have, when I hooked it up to the power source, I made a custom wire harness that will disengage the battery when you shut it off. Okay. So if you plug it into wall, it can run off of AC by itself. If you want to charge the Bioenno simultaneously, all you do is turn the on switch on. That will turn the power onto the battery and it will charge the battery while you're running on AC. Same thing if you plug in the solar power into the back. The Epic Power Gate does all the switching for me. So the second I plug that power and sees it from the solar power, it does its own switching. Now it's running off the panel and maintaining the battery. Everything runs flawlessly now. It's really, really excited about this build because, again, this was not something that I engineered first and drew the circuits and, did an appropriate implementation. This was like all of my bug out boxes, the blind leading the blind. I come up with a design, I engineer it, I fabricate it, and I do it one thing at a time. One of the really cool things is with this FTM 300, this is the first Fusion box that I've built. And the FTM 300 has the sickest mount. It's a quick release mount with the little spring lever. You just click that spring. That radio you can pull out of there in literally under 1 minute. You undo the power pull, you unscrew the antenna, you click the quick release for the power mount, you pull the radio out. Now you're doing your updates. It's very easy. And it's very serviceable. So everything was designed and put in place so you can access it. If something goes wrong, you can fix it, and fully self-contained. So with that MFJ 1717, literally put that antenna on, turn the power on, and PTT. It's pretty bitchin'. It turned out real nice.
What's your input power restrictions? Like I see you got a computer plug, I forget what connector that's called, but those are also modules, so you can actually use a 220 connections to them. Is that also down the electrical into it? So if you were in a scenario where you only could plug into another server rack, could you plug into 220 with that, or is that 120 based only?
120 based only. Yeah. Honestly, I didn't even really think twice about 220 or being in any type of a power source where you would have to step it down from 220 to 120, 110, whatever. I really didn't put a lot of thought into that, not thinking about her going to Europe or using a huge power source where she could plug in and
yeah.
That's this radio.
Yeah, because a lot of server racks actually run on a 208 plug as opposed to a 120 plug.
Okay, yeah.
I do a lot of semiconductor facilities. That's why we just run a lot of 208 30 amp or 208 20 amp circuits to large power strips, and that's what we plug all server racks into.
That's cool.
And then the other thing I had was your solar. How does it know which voltage? Is there an MPPT that needs to be plugged in before that, or a PWM, or are you just plugging in a direct 18 volt, 12 volt solar panel?
No. The PowerWorks solar controller is very diverse. It operates with a voltage input from 20 to 50 volts.
Okay.
And it changes the voltage to 14.5 or 14.3, whatever the Bioenno. It's actually set up for all battery chemistries, and there's a jumper inside the Epic Power Gate. You've got to take it apart. Once you've decided what battery discipline you're going to use, lead acid, AGM, or lithium polymer, you will put the jumper on there specifically to complement the battery chemistry that you're using. And what's really cool about the Epic Power Gate, it's got a USB output and a program. You plug it into your laptop, and you can custom configure the output voltage to accommodate whatever voltage is going to be absolutely perfect for the battery system that you have. So, the Bioennos, they like 14.5 volts, lead acid, 13.5 or below.
So by the sounds of it, you can also use a secondary battery to expand the capacity if you want to plug into that as well.
That's absolutely correct. And that's one of the cool things. I've got what I call the Bobby umbilical box, which you might not have seen the other builds, but I've got a really unique VHF, UHF commercial dual band in a really custom case that it's actually from you may or may not have heard of it, but it's called a Firebird 6000, and that's BERD if you wanted to look it up. It's a Firebird 6000 communications analyzer. And I found this thing at the flea market in perfect working order for $25. I was only infatuated with the case. When I saw the case, I'm all, this thing is bitchin'. I could build something cool out of this. Had no idea. Thing sat in the garage for months. I did plug it in. It worked perfectly. I found it actually on eBay for $300 to $700 in working order, and I gutted it and took it all the way down to the chassis, ripped everything out that had to do with the Firebird 6000, and it hosts a it's the PowerWorks 750 DB or something like that. It's a dual band commercial rig, so it's opened all the way. You're doing ham, you're doing commercial, whatever. But all of the radios that I've designed to be able to parallel the batteries. I can hook all the batteries up in one right now and get 52 amp hours, I think, total to run everything.
You need to plug one of these guys in.
Right? The hell is that?
Little homebrew battery, yeah. 52 volt or 58 volt lithium polymer 18650 15 amp hour.
Nice,
Little
nice.
homebrew project.
This box here has a Bioenno 20 amp hour. The other box with my HF rig has got a 20 amp hour lithium polymer. And then the smaller box with the dual band radios has a 12 amp hour Bioenno in it. And they literally can all connect together. They're stackable. It's my all-in-one, but it's stackable. The VHF, UHF sits on top of my HF. And the way that it works, I'm capable of running 3 bands in my all-in-one simultaneously. My HF rig hosts a Panasonic Toughbook. That was the biggest challenge of the build, is I wanted to be able to carry the box and everything be in it. So in the back of the box, I'm pulling out a Toughbook and I'm pulling out a iPad and putting it in there. And the box has also got an SDR Play mounted. So you just pull that USB out, plug it into the Panasonic Toughbook, and you have a 12 or 14 inch waterfall instead of a whatever those are, 4 or 6 inches, whatever, some of these nice modules. And when you lay it out on a table, you would have the full array up in front of you, and you could probably see the radios on my QRZ page, but they're poor pictures. But you would, if you typed in KD6 KWV and QRZ, you will see both of those radios stacked on top of one another, so that'll give you a better picture. And then the laptop would sit on top of the VHF. One iPad sits to the left, one iPad sits to the right. So I use the laptop for the nice waterfall and other things, of course, if I want. Everything's running off of my Jetpack. The iPad 1 will be hosting my QRZ if I'm doing logging, and the iPad 2 is hosting my Pi-Star Dash. And one of the cool things that I did is the HF box has got built-in tuners, built-in SWR meter, but the SWR meter is 2 meter, 440, and HF. So what I did was I actually put PL259 inputs and outputs. So when you stack the top box on the bottom box, top box being VHF, UHF, there's a port on the back of the HF box. You screw your antenna into that. Now you have full usage of the SWR meter for VHF and UHF, including HF. And then it has an external antenna, so then you just run your dual band antenna for that. It's got the HF antenna outlet on the back, so I run my inverted dipole on the back of that. And all of this was trial, and again, I wasn't engineering this. These were things that I put together during COVID to help kind of inspire hams when we were all locked down in a shitty situation. And I wanted to inspire people to have some fun and feel good while we were locked down. And my emphasis was whatever I could find on my bench, on a shelf, or in a drawer. And then I just custom fabricated every bracket. The HF's got an 891 in it with a MFJ auto tuner and a diamond SWR meter. Now that box with the HF has got 2 dual USB ports, one on each side. It's got the Anderson power pole, it's got dual Anderson power poles, one externally, so you can plug in things. It's also got the solar input. And then on the back of it, same thing. If you're running off of AC power, one of the ports from the power supply goes to the back. So if you're running AC, you've got that running. Very cool. It's like when I did Sandy's build, it was the first build where I actually, I actually put things on paper, and designed it, and then did all the electronics as far as running wires to where I needed to run wherever, but it's essentially taking a BioEnno battery, a PowerWorks PD8, which is 8 power poles. Plug into one, you've got 7 left, so that distributes my power. The radio, of course. The
So
power.
where does the Pactor fit in? So I can
Where's
send
the-
an email.
Hey, you can give me more ideas, man. I'll just put it in a box. Well, Sandy, what do you think about the new box?
It's mine. It's all mine.
It looks good. Looks
It
awesome.
does.
He did a good job.
Yes, he did a very good job. And
Bravo.
yeah, I'm speechless.
Yeah, don't be
Hi.
shy.
Here's Connor, K7CBL, located in San Mateo.
Oh,
Heard
yeah.
you guys out here on the 3-3 sometime, so I was like, all right. And I saw the live stream. I just got home from field HF stuff, so just kind of messing around.
Connor, San Mateo. Where in San Mateo, at, dude?
I'm in Shoreview.
Shoreview. I lived over by Beresford.
Yeah.
Oh, there he is.
Yeah, dude.
Hi. Yeah, my California room right here.
I love it. Love it.
Yeah.
Ranger.
That's right.
Yes, I did, and it went to somebody
Wow.
who's actually using it right now.
That's
Yeah.
awesome. Congratulations, bro.
I was a little butthurt. I didn't win the radio.
Oh,
I was butthurt. I didn't hear or see any of it.
Hey, I've got the. Hold on, let me grab my hat really quick.
It's funny as I checked in and I didn't even know you were giving out a radio.
Now, I should ask Connor, is that a real background or are you one of those Slim Shadys that puts the fake background?
Oh no,
in there?
this is real. This is all real.
Hey, does anybody have any
real.
other questions? I got to take the kids and get them ready for bed.
Oh, you're out to work. Kellen, thank you very much
Yeah,
for
that's a good question.
a great presentation.
Okay,
Hey, are
cool.
you going to be on the 3-3 tomorrow morning as you go off to Stuck in Old Lodi?
Yeah, I'll probably crank it on at about 5 a.m.
Okay, I might try to catch it. Maybe we'll catch a green donkey too.
Oh.
Thank you, Kevin.
Yeah.
Awesome, great job. Thank you, man.
Excellent presentation.
Just be
dude.
prepared
Thank
for the
you so
next
much.
one, man. We'll definitely have you back
Hey,
out.
that's what 24 hours notice kind of like a, hey, let's get this going. And learning how to use PowerPoint
That's
again,
awesome,
you know?
dude. That's awesome. Hey, I'll give you credit for your electrical skills, your electrician skills. You get no PowerPoint skills tonight.
Oh, that's
no
I
points
got
that one
squat
tonight,
for
dude.
like I
If
hey, I
Hey,
said
forever.
early on to Nick, I said, computers and me, we don't really get along. That's why I don't do anything digital. It's all all analog. I like to talk to people. I don't push
I'm
buttons.
just giving you
Old
just giving
school.
you a hard time. Great. It was a great presentation.
Okay, thanks, Kellen. Good
Cool.
job, man.
See you later. Have a good night.